Hello, I'm Jenny Beale, and today I'm with Francis Lucille and Professor Donald Hoffman. So, hello, Francis. Hello, Don. And for those of you who haven't come across either either one of them before, Donald Hoffman is a professor of cognitive sciences at the University of California, Irvine, and he's developed a revolutionary theory about the nature of consciousness. And Francis Lucille is a spiritual teacher in the tradition of Advaita Vedanta, non-duality, having studied for many years with Jean Klein. And he also has a background in mathematics and physics. So I gather that you haven't really met before, or at least haven't discussed your ideas before. Is that right?
That's right. It's a real pleasure to meet you.
Yeah.
Absolutely.
So it's great. It'll be your first discussion together. So to start with, I'd like to ask you both, in your view, what can science tell us about reality? And also implied in that, what are the limits of science? What can't it tell us? So who'd like to start?
Well, I can start.
Please.
For me, reality is, we know that there is something rather than nothing with absolute certainty. But we don't really know what that thing is. And for me, reality is the thing that is. It is also, if you will, what Parmenides defines as being, or what Spinoza defines as the substance. He defines the substance as that which cannot not exist, that which exists, which is by essence. And as otherwise also, it follows that it is that which is cause of itself, which the existence of which doesn't depend on any external reality. So for me, that's the ground of being. And yes, that would be my definition of reality. And my definition of consciousness, because I assume that we are going to go into this, to travel on those roads. Consciousness is the reality which is hearing these words right now. So these are my two definitions.
Yes, well, that I agree. And in terms of science and its abilities and inabilities to give us a theory of reality, I would say that each scientific theory must start with certain assumptions. And if you grant those assumptions, then the theory says, I can explain all these other wonderful things. But what the theory doesn't do is to explain its assumptions. It assumes them. So that any particular scientific theory is never a theory of everything. It's going to leave something out. And you could say, well, no problem, I'll create a new scientific theory that explains the assumptions of that prior scientific theory. And that's perfectly fine. You can do that. And that's part of a thriving science to do that kind of thing. But the new theory will have its own assumptions and that it doesn't explain. And so my view is that science, of course, I'm a scientist. I think science is an incredibly powerful enterprise. And I love the precision of the mathematics and the theories of science. But I think that the fact that scientific theories are always if-then kind of statements. If you grant me this, then I can explain that, means that science will forever barely scratch the surface of reality. It's the best tool, one of the best tools we have for probing reality, and yet science will be forever condemned to only giving us what I would describe as wonderful descriptions of certain, perhaps trivial projections of reality. And so even though I'm a scientist, and I think that science is an incredibly powerful tool, one of the best tools humanity's ever stumbled across, I think that the hope that some scientists have expressed for a theory of everything is not possible. And I think most scientists who talk about a theory of everything, it's with a wink and a nod, because they know full well that we're nowhere near close. And I think they know full well that in principle we could never get there. So it's an interesting balance that I think that we have to strike. I am a scientist, and I love the mathematical rigor of science. I love the careful experiments of science. I love the restraint of science, where you try not to go beyond what your theory and your data will allow you to, cleanly assert. So it's extremely important, and it's revolutionized humankind's living standards with technology, as well as intellectually. But I think part of science is what science teaches us is also the limits of science. And now, of course, this is very similar, I think, to what many spiritual traditions have said about what they say about religion, or about reality. And that is that the words of the spiritual traditions are just pointers, right? The finger pointing to the moon is not the moon, kind of thing. And I think the same thing is true of scientific theories, that the scientific theories are pointers. They're not the truth, but in some sense, they're the best pointers we have, because there's something unique about the pointers of science, and that is that the pointers for a good scientific theory, the pointers of a good scientific theory, tell you their limits. The scientific theory actually tells you in unmistakable terms where the concepts of that scientific theory stop. And that's something we can't get unless we have like the mathematical precision of a scientific theory. And so for example, Einstein's theory of space-time, which is an incredibly powerful framework. It's, his theory of general relativity is made all sorts of incredible predictions that have turned out to be verified in experiments. But his theory, when you combine it with quantum theory, tells us that the very concept of space-time that Einstein uses has no operational meaning at 10 to the minus 33 centimeters and 10 to the minus 43 seconds. And so that the scientific theory, which is pointing, a theory of space-time, which is just a pointer at I would say, a particular perspective on reality, is telling you the limits of that perspective. This particular perspective of reality of space-time falls apart at 10 to the minus 33 centimeters and 10 to the minus 43 seconds. And so that's what's really, I think, powerful about scientific theories. In terms of Jenny's question, how far can science go in explaining reality? Well, what's really interesting about it is that I think it goes maybe 0% of the way, literally 0% of the way, and yet it's the best tool we have, because the very theories of science tell us that they're just pointers, and they tell us precisely where those pointers fall apart. But I should stop and let Francis, I'm sure you have thoughts.
Well, I agree with everything Don just said. Also, we have to understand that the scientific method has a limited scope. It is restricted to the realm of phenomena. As a result, the goal of science is not to answer the question, what is it? Or even the question, why? But simply the question, how? Most of science, I'm not at all knowledgeable about biology. I'm a little bit knowledgeable about physics. And it's to be able to describe how systems evolve. Basically, that's an element of, if we do this, then in a controlled environment, then we'll get that. And that's the laws of motions, the equations of motions. And you find that basically the math, you have two things with an equal sign is between, which means that if I tweak this that way, the other side is going to tweak accordingly. It's a kind of accounting. So limited the scope to the realm of phenomena, but not only to the realm of phenomena, but there is another requirement, which is peer verification and the ability to reproduce the experiment and to have a peer verify it. So that excludes, for instance, a one-of-a-kind event. A one-of-a-kind event, we can only have theories about it, but we cannot, if we cannot reproduce it, science, it is not a scientific event stricto sensu. This requirement of peer verification somehow excludes pure subjectivity. Because how can you introduce pure subjectivity and meet the requirement of peer verification? However, I find science quite beautiful, and I'm not at all into New Age stuff. I love the scientific method. I love the requirement of verification and falsification of a theory, and where the rubber meets the road, so to speak, the predictive value of a theory. And so the way science progresses, at least it seems to me in the realm of physical science, is that the new theory doesn't cancel the previous theory, but expands it, is able to explain more phenomena, such we had electrostatic in the old days, and we had magnets, and then Maxwell comes and puts electricity and magnetism together. We had the law of conservation of momentum and conservation of energy as two separate hypotheses. Then Einstein comes with special relativity, and then we have a four-vector energy momentum, and that's that which is conserved through a Lorentz transformation, and that unifies, that simplifies, although the equations are more complicated. But for the mind of the scientist, it's a simplification. The equation of general relativity are very complicated. There are differential equations, system of differential equations, and they are very complicated. But in fact, it simplifies our understanding of nature by, for instance, before that we had two kinds of masses, the inertial mass and then this Einstein proves why the inertial mass and the gravitational mass are the same. So it's a simplification for us, for the one who have gone through the pain to understand the equation. Yes. And so science is a beautiful endeavor, and because of my interest for consciousness and reality, one day I was giving a talk at UC Berkeley, and Geoffroy Chu, who was the dean of physical science and one of the father of quantum, of the S-matrix theories and the bootstrap theory, came to we were acquainted. He came and he asked a question, Francis, what's the connection between what you're saying and quantum field theory? And I said, no connection. I love science too much and then he came after the side, we had a little chat, and he said, I have nothing to, I have no objection to everything you said. And I feel that's, I have always kept these two domains separate. However, and that's where, with a secret hope that a new physical theory could take birth being inspired by the metaphysical or the ontologic understanding that consciousness is the ultimate reality. I've always, and I know that you, Don, lately I've been on the internet, looked a little bit at what you say, and that space-time has its limitations. You explain why, and that's a very good argument. The fact that if we go to the high energy level, meaning very small distance towards the Planck distance, if we want to have access to this domain experientially, then we create a black hole, and the more energy we pump into it, the bigger the black hole. Basically, we have no access to this domain, and that limits. Another reason, actually, that I find a limitation of the current view of space-time is the fact that in the two main theories, physical theories that are available right now, quantum theory, including quantum field theories, and general relativity, the time doesn't play the same role. In general relativity, space-time is like a fluid. It's really an object. It changes depending on the local distribution of mass and momentum. It gets some curvature. So, whereas in quantum mechanics, the time is like a clock ticking away in the distance, imperturbable, unaffected by anything. So this inherent contradiction between the two shows that if we want, I mean, to me, I'm not a physicist, that if we want to unite and to have a deeper physical theory that will encompass more phenomena, we need to go at least beyond time. We need to go beyond time. And so we need to go beyond space-time, yes, as we know it. And I think that is something that is in the minds of contemporary physicists more and more.
Absolutely. A lot of good points there, Francis. I'll pick up on a couple of them. First, I certainly agree with your idea that we have a sequence of scientific theories, and that, we want our new theories to, in some sense, comprehend the older ones, generalize them, and offer us a bigger scope of explanation than the previous theories. And one thing that helps scientists make that transition from one theory to the next is the fact that a good scientific theory tells you a little bit about what it can do, its scope. A great scientific theory tells you about its limits. It tells you what it can't do, right? So Einstein's theory, together with quantum theory, tells us what it can't do. I can't tell you what happens at 10 to the minus 35 centimeters. Can't do it. Can't tell you what happens at 10 to the minus 40 seconds. Can't do it. That's beyond my scope. So the theories tell you those limits. A great theory will tell you those limits. And that then is the trigger for exactly what you were talking about, which is, okay, if that's the hard limit of our current theory of space-time, then we, as scientists, don't want to stop there. We would like to go deeper. What is there a deeper theory of space-time, or is there some theory of something beyond space-time that projects down to space-time? So like, that's again the issue that, or the power of scientific theories, that they're so precise, that they're precise pointers, and they point not only to what they can explain, but they also point to their own limits. And that's one thing I love about scientific theories. Now, what's remarkable is it's the theory itself, the mathematics of the theory itself, that we're using to show its limits, right? It's using Einstein's equations together with just one other equation, basically, that E equals h nu. All you need is Einstein's theory of gravity and E equals h nu to come to the conclusion that space-time cannot be fundamental. It falls apart at the Planck scale. And when we are doing that, it's very much an inside job. We're using the theory itself to, in some sense, find the limits of that theory. And that's what I find incredibly beautiful. Now, I've done the same thing with evolutionary theory, using the concepts of evolutionary theory as they're embodied in the mathematics of evolutionary game theory, to also show the limits of the application of the concepts of, for example, organisms and resources that are central to the notion of Darwin's theory of evolution. And so once again, it's using the mathematics of a scientific theory, not only to explore its scope, but also to find the hard limits, the limitations of that theory. And so that's what's, I think, an incredibly powerful thing about science. Now, it's interesting that some philosophers have actually criticized this kind of approach and saying that it's self-refuting. So that what I've just described can't be done because it would be a self-refutation, shooting yourself in the foot logically. So, for example, in the case of the theory of evolution by natural selection, and its mathematical statement in terms of evolutionary game theory, so what they'll say is either the mathematics of evolutionary game theory faithfully represents Darwin's ideas, or it does not. If it does not, then of course you couldn't use it to refute or find the limits of Darwin's ideas. It would be pointless. And if it does, if the mathematics does faithfully represent Darwin's ideas, then it couldn't possibly refute or show the limits of his concepts. And it's that last step that they make, which is an error. It's absolutely a mistake to say that if you use the mathematical statement of a set of concepts, that you can't use it to find the limit of those concepts. And a good example of this is the well-known incompleteness theorem of Gödel. Gödel uses the axioms of arithmetic to actually show the limitations, the incompleteness of the axioms of arithmetic. And that's exactly what science is up to as well. We use the axioms of Einstein's theory to show the limits of space-time. We use the axioms of Darwin's theory, when it's mathematized, to show the limits of the concepts of Darwin's theory. And that's how science, in some sense, pulls itself up by its bootstraps. Its great theories give you the tools to find their limits, and then that inspires you to move beyond. And then when you move beyond, what's nice is what's fun, especially if you're a young scientist, is of course you get to be the discoverer of the old generation's theory doesn't work. You now have proved that the old generation's theory doesn't work, and the young generation gets to take the next step beyond, and that's always fun. It's a new adventure. The old theories can't tell you where to go, right? Einstein's theory of space-time can't tell you what's beyond space-time. It's only a theory of space-time. So you have to take a creative leap, which is also fun. You have to go and
But the new theory has to recover the
Yes.
old theory as a special case. For instance,
Absolutely.
h bar equals 0.
Exactly.
Right?
Or C equals infinity.
Or V, in the case of beta or V over C, V equals 0, or things like things of this type. We need to recover, otherwise we are just on flying at 30,000 feet without ever landing onto reality, and the actual verification or falsification of the theory using the means at our disposal. Right? So a new theory, even if let's assume we have a new theory that tells us that makes assumption about what is going on inside black holes. So someone could say, yes, we cannot go into a black hole to verify or falsify the theory. But let's assume that the same theory explains what we know already and what is already explained or accounted for by the existent theory, plus has a predictive value of some phenomena that we may discover by reviewing the data that we have gathered from our observation, and find some regularities there that are not accounted for in the existing theory and now are accounted for in the new theory. Then we say, okay, great, Nobel Prize for the guy who has discovered that. So that this requirement of verification or falsification is so important, and at the same time, the inclusion of the past pre-existing theory. So it's a kind of a succession of sets that are including the previous sets. Right?
I completely agree. In some sense, the old theory can't tell you where to go next, but it can say no. When you say, I have this idea, I think this is right, and then it comes back and it says yes or no. What it can say is,
you have to allow thinking out of the box. Yes, definitely.
You have to allow thinking out of the box, but then you can take your theory beyond space-time, project it back into space-time, and Einstein's theory goes thumbs up or thumbs down about the projection of your theory. And so it continues to serve an incredibly valuable service there. And by the way, there's a new European Research Council initiative, I think 10 million euros, studying what they call positive geometries beyond space-time. What they've realized is that space-time and quantum theory cannot be fundamental, and they're now jumping in with a lot of money and a multinational, international team of mathematicians and mathematical physicists to study what they call positive geometries, which is the best guess we have right now about the next step beyond space-time. But what is the first step beyond space-time? And so that's pretty. So we're in this is only these positive geometries have really only been out, say, in the last 10 years, maybe 15. So it's all brand new stuff, and science is now taking the first steps outside of our headset, which is it's an exciting time to be alive in that regard. Mm-hmm. But I wanted to actually respond also to something else that you mentioned, Francis, and the relationship of consciousness and quantum theory. And I certainly understand wanting to be careful about that relationship and not overstating it. But there's an interesting interpretation of quantum theory called cubism, QBISM. Chris Fuchs, Rudiger Schock, David Merman, and Marcus Appleby and others have developed this fascinating interpretation of quantum theory, in which it's the wave functions are simply probabilities, subjective probabilities. So what they do is they have a subjective Bayesian kind of approach toward interpreting the mathematics of quantum theory. And when you do this, it turns out that a lot of the weirdness and problems with quantum theory disappear. Collapse of the wave function and so forth is just simply as, if I, it's no more mysterious than if I have a die and I haven't rolled it yet, and you say to me, so what is the probability that is going to roll a 3? And I say, well, I would have to say 1/6. And then I roll it and it comes up 2. And then all of a sudden, then you say, well, now what's your probability that's a 3? Well, my probability of that is 0 now, and my probability of 2 is a 1. And so in some sense, we wouldn't be mysterious about, well, my Hoffman collapsed his 1/6 to 0 and 1 there. So what happened there was a collapse. No, I got new information. I updated my beliefs. And so
the state vector encapsulated all the knowledge we can get about the system, right? So basically, it encapsulates information, right?
That's right, in a probabilistic framework. And so the only key thing here that they say is the probabilities are not objective probabilities.
It's amplitude.
Well, the amplitudes, right? It turns out that there's a 1-for-1 mapping between amplitudes and probabilities. So you can show that amplitudes and probabilities are just different languages for the same thing. And this is, again, if you're interested, there's a paper by Chris Fuchs and others, on quantum Bayesian where they go into this. So you can actually translate between the, well, I'll put it this way: the amplitudes are.
You cannot move from probability to amplitude. You can move from amplitude to probability by taking the modulus,
right?
But you lose the phase, right? So you cannot really, there is not a bijection between amplitude and probabilities.
Well, yeah, Chris Fuchs actually shows a functional relationship between them. And it is a bijection, actually, when you write down this functional. So I probably shouldn't go into the equation here, but I can send you a paper. So you're right, it's not trivial. The connection between the two is not trivial. And it involves the dimension, basically the dimension of the quantum system that you're dealing with. So basically the probability is a functional of the normal Bayesian probabilities. You have to take them and multiply them by d+1 and then add 1, I think, or something like that. And so you get what's interesting is they have figured out a functional between the amplitudes of quantum theory and the probabilities of subjective belief. So their interpretation is that,
you mean by adding a dimension to the Hilbert space or whatever?
Well, it's literally just taking the standard Bayesian probabilities and multiply them by a term which is d+1, where d is the dimension of the Hilbert space of the quantum system that you're looking at. So this is probably maybe more technical than we want to do here, but I can send you a paper about it. But it is this very interesting relationship. The key point here is that it's mathematically permissible to reinterpret all of the wave functions in quantum theory in subjective probability terms. You can do that. And so you're going to get then that the wave function is specific to the observer, to the scientist or the agent that's making it. Your wave function could be different from mine because you have access to different information than me. So this is how they resolve some standard classic problems in quantum theory, like Wigner's friend, right? So you have, some Schrodinger's cat kind of situation, right? Where there's a cat in a box, and then
the collapse of the state vector, yes.
Right.
Yeah. But for me, the fact that we have amplitude and not probability is so fundamental in quantum theory because
it is.
Because of quantum interference. And that's the essential point. If you don't have, if you don't have this amplitude element, and that's why we have the complex numbers and in the theories, that's what we have, waves and not just particles. So the wave-like aspect of physical reality is kind of encapsulated in the complex numbers that are part of the theory.
Absolutely, absolutely. And so Chris Fuchs, who is a quantum information theorist, goes into that and explains how the two are related, even though the amplitudes have all this, complex interference stuff going on. How the two are related.
But what you said, there is something interesting, because information, right? Because then we move from the physical aspect of reality, energy, so to speak, to something more subtle, which is information.
That's right.
And of course, we have embedded in quantum theory, we have embedded conservation of energy because of the symmetries of the homogeneity of time, right, and the symmetries of space-time. We have also the unitary evolution of the systems,
right.
Which implies the conservation of information, right?
Right.
And so these are the two. And there are basically three levels. The physical level, energy, a more subtle level, information. And then there is another level, which is the level of meaning. And what strikes me is the reductionism, and in fact, it's an act of faith, it's an act of belief. There is no scientific evidence in support of that downgrade meanings to information and then information to matter.
Right.
As if there was a hierarchy that starts with matter, right? And then information and then meaning. But if we run a simple thought experiment about meaning, meaning being essentially different from information, we have a translation, a program, translation from French to English, right? And this program works fine for simple sentences, such like, Don, I would like you to come to my place for dinner tonight, right? And so we put that in the computer translates that into French. The guy who doesn't speak English, but French, understands it perfectly. Now, we replace the computer with a Chinese guy who doesn't speak English or French, right? But he's given all the dictionaries, grammars, and, in other words, all the data which is available to the computer in the memory of the computer, plus the program, the set of instructions of the computer in Chinese, right? In Chinese. So the guy goes step by step, and basically he runs the program by going to this book, looking at the information, etc. He just set. It takes him much longer than it takes the computer, of course, but he ends up with exactly the same outcome, right? He has translated from English into French. He doesn't speak neither French nor English, so at no point has he understood the meaning, right?
Right.
He has access to the information, he processes the information, he has no access to the meaning. Then, why would we believe that a computer that does exactly that could have access to meaning? If the Chinese guy who acts as a computer doesn't have access to meaning, why would you believe that the computer, which is a physical system, would have access to meaning? Obviously not.
Right.
And then we go further. If we have determined that a physical system doesn't have access to meaning, then we look at the human body, made of quark gluons and leptons, right? This human body is a sophisticated mechanical architecture, right? It's a supercomputer, but from that vantage point, from the vantage point of physicalism, it is a machine. So no matter how sophisticated the machine is, if the computer doesn't have access to meaning, why would this human computer doesn't have access to meaning? It is not the machine, the human body who has access to meaning. That goes very far, you see.
Yes.
It is something which is not physical, which has access to meaning. It's something which is irreducible or irreducible to physicality, that has access to meaning. I don't know. I just leave that as food for thought.
That's a great thought experiment. You're probably familiar with John Searle, who is famous for putting out that very same thought experiment.
That what?
John Searle, who's a professor of philosophy at Berkeley, is quite famous for the Chinese translation argument that you just gave. And Searle makes the same point about meaning from that. Absolutely. And I agree. Now, Searle wants to then say that somehow the biology of the brain somehow does that, right? And there I disagree with Searle, and I agree with you that we have no reason to take the brain to be anything other than a machine from a physicalist, a probabilistic machine, but nevertheless a machine. But I think your point is well taken, that there is a notion of meaning that's very important here, that is not captured just. The semantics is not captured by the syntax. The syntax and semantics mesh, but the semantics is not reducible to the syntax. And I think that that's another way of making the point that we sort of started with, which is that a scientific theory is, in some sense, a mathematical statement. It's a formal syntactical statement, and we interpret it in terms of what it means, and we find that it has limits, and so then we have to come up with a new scientific theory. And so we, the scientists, are the ones that understand. The theories don't understand. We're the ones that create the theories. The theories are just syntactic tools that we use to capture a little bit of the meaning that we already understand ourselves, but are trying to clarify in some sense. And so it's very interesting for me as a scientist to see this interesting dance between meaning and syntax. It's not like the syntax is merely the slave. The syntax, when I take my ideas, the meanings, and I turn them into math, like Einstein took his, well, you talked about general relativity and the equivalence of inertial and gravitational mass, right? Einstein's intuition there was if he was in an elevator standing on a scale, weighing himself, and all of a sudden the cord of the elevator was cut, he would weigh nothing. All of a sudden he would weigh nothing. That was his big idea. And it then took him several years to turn that into the field equations of general relativity. He was Einstein, so it was a hard task. But what happened was then, even though Einstein was the one whose deep understanding of meaning led to the syntax of general relativity, the equations. The equations came back and taught him deeper meaning. He did not know that his ideas entailed the existence of black holes. He didn't know that. And when Schwarzschild, a few months after he published his paper, when Schwarzschild came back to Einstein and said, here's your equations solved in a special case, and they tell us that there are black holes. Einstein didn't know it. He didn't believe it for a long time. He disbelieved in black holes. And so what's interesting that So I completely agree with you, but the relationship between meaning and math or syntax is really quite subtle, because in some sense the meaning gives birth to the syntax. Einstein wrote down his equations based on his ideas, but then the syntax comes back and takes you to deeper levels of meaning. There are black holes that you never even dreamed of. And that's the virtuous circle that science gives us, that there's this loop between meaning and syntax, because we take our meaning and make it really precise in a syntax, and that syntax comes back, and we become the students of our own syntax. And then, but then we get a deeper appreciation of the meaning, and that then leads us to create a new syntax, which is richer. And so that's a really interesting virtuous circle that we get in science, and this is what I'm hoping will be transported to spirituality. Spiritual traditions clearly tell us that what they say is just the syntax, it's just a pointer, is not the deep meaning. It's just a pointer to the meaning. You've got to experience the meaning yourself. But what the spiritual traditions haven't yet had access to is this virtuous circle of taking your meanings, your spiritual meanings, turning them into really precise pointers that are precise enough to become your tutors, at least for a while, until they take you to a deeper level of meaning. So that's what I'm hoping in the interaction between science and spirituality. Spirituality has already some very, very deep insights from meditation and so forth. What they do, and they have certain set of pointers, but not pointers precise enough to become our tutors. For that, you need mathematics. And so that's what so now a lot of people say, no, well, you can't take spiritual ideas and turn them into mathematics. I say we don't know until we try. Let's see if we can actually, but with this proviso, the math is never the territory. The math is just a projection of the territory. But we've learned from science that projection can be our tutor and help us to get to a deeper level of meaning. And I think in spiritual terms, that the math could actually take us to deeper spiritual insights that we've never had before, and expand us that way. What I see going on in spirituality, I mean, my dad was a minister in a Protestant fundamentalist church, so I have quite a bit of schooling in Christian fundamentalism. And then I've read a little bit about Buddhism and Hinduism and other religions. And what I see is that there's a real common theme among many of them at their core, especially among the more mystical aspects of these traditions. There's something very, very deeply common about them. But the language, for me, is suggestive and helpful, but imprecise, and that imprecision has two fallouts. One is, first, we don't get this virtuous circle that I was talking about. You don't get the benefit of in some sense being surprised, right? Einstein was surprised by the equations he wrote down. So, and it was a good surprise. But the second thing is that if we look at the history of religion, the great teachers have been very careful to say to their followers, the words are just pointers. Don't take them literally and don't be attached to those words. But the followers repeatedly ignore the teachers and become dogmatic, and eventually then kill each other.
And create religions. The ones who don't get it, the ones who don't get it, create religions and belief systems, whereas in fact, spirituality is very much like science. My teacher used to say that philosophy is the love for wisdom, And wisdom is a science of happiness. In other words, it's experiential. It's just that it's like living our life. That's conducting an experiment, conducting a series of experiments. And it depends the perspective from which we live our life. If we live our life from the perspective of being a separate consciousness, there will be some outcomes. If we live our life from the perspective of our seemingly ordinary consciousness being in fact universal and being the reality, the absolute reality, there will be different outcomes. I mean, not always, but there will always be circumstances, a context in which our decision or our thoughts or our feelings will be different depending on where we go when we reach this fork on the road. And so in this way, wisdom and philosophy become scientific in that sense that we conduct experiments, not experiments of the kind we conduct in physics, no, but a different experiment. And what is tested here, the theory which is tested here, is we are asking from the universe, from reality, the question, is there one reality only? Or is there a multiplicity of realities? If there is only one reality, it implies that this consciousness which is hearing these words, that which is really hearing the words, has to be this reality because there is only one reality. You see, it's this deep implication that seems obvious, perhaps, but that even those who believe, they are certain that there is only one reality, mainly 99% of scientists, right? After all, they would say, there is only one reality. Of course, I am in the process of studying the laws of this reality.
Right.
But then, when they are dealing with their child, with their spouse, then all of a sudden they become a separate reality, right? So that's a different question. But spirituality, for me, is the science of not knowing. Because in order to understand, we need to be in a state of openness, not to know.
Yeah.
If we know, we really don't know. That's a Tao Te Ching, right? The one who knows doesn't know, the one who doesn't know knows. We need to have this openness, this not knowing, in order to be able to discover.
Yes.
And life is a constant field of discovery, and that's what makes life interesting. We are always at the university of life, right? In our life, in your vocation as a scientist, in my vocation as speaking about not knowing and about the truth, and that's nothing is taken, nothing is given for, it has to be taken for granted. Everything is new, everything is on the table at every moment. It is this openness which is in fact the beauty and the perfume of life. But there is something else. When we are open to the possibilities that this apparently limited and apparently human consciousness is in fact universal and is in fact the reality of everything. It is not that consciousness is human, it's that humans are consciousness. Then, in the sense, the sense of impending doom, the death, the fear of death goes down the drain. You know, and that enables us to live our life to its fullest. Because there is plenty of time, you know. If if the death is right there, you know, I have to multiply the experiences, and finally, I'm not going to enjoy anything. So there is, in this relaxation, in this openness where we allow for life to speak to us and not speaking to life, there is happiness, there is understanding, there is love, there is beauty, there is harmony, the hidden harmony behind the perceptions. What you said about the theory coming back at itself somehow, you know, it reminds me, there is another example of that, which is the Dirac equation and the discovery of antimatter as of the positron, right, as some weird solutions of the equation of the spinor with four components, and the other one was the two versions of spin up and down. So basically, the fermions, the fermionic field in the free particle setup. He starts with an equation, right? He starts with, he wants basically to linearize the Klein-Gordon. He wants a linear equation. And in this process, he finds a very smart way to factor operators. And in this process comes the spin, comes antimatter. Of course, it was not, who would have predicted that? The mathematics, it is a mathematics. They come back with a vengeance because they reveal very hidden implications and theories. It is not true simply from mathematics as applied to physics. It is also true within mathematics. Who would have thought that the solution of Fermat theorem, the Fermat conjecture, would have required such a paraphernalia of algebraic geometry and other stuff like that, which apparently had nothing to do with this very simple equation in natural numbers, right? And that was hidden. That was hidden in the mathematics, and that's why a mathematician feels that he or she is discovering a territory that already exists, right?
Don, there was something rather similar when I first read about your theory, a similar element of surprise. Well, the first surprise was that you started from the idea that consciousness is primary, because most scientists and most of the science I have read about consciousness assumes it's a product of the brain. But it was when you tried to make it mathematically precise, and then what came out of that, using Markov kernels, and then what came out of that was the idea that there is just one consciousness, so one reality, and that fell out of that that mathematical model that you produced. That was totally amazing for me. I don't know whether you could say something a bit more about that.
Yes, and this again is a very interesting interplay between the meaning and the syntax, the meaning and the descriptions. What I have done with my colleagues for several decades we published a book in 1989 called Observer Mechanics. And it's a theory of consciousness being fundamental, and it's a dynamical system, a Markovian dynamics of consciousnesses. And I've continued to develop, I now call it a theory of conscious agents instead of just observer mechanics. And it's Markovian dynamics. And it has interesting, I can model a conscious agent by a sequence of Markovian kernels. One, so a conscious agent, just a little technical about the definition that we're using. Conscious agent has a set of possible experiences, maybe just like red or green for simple conscious agent. That's all it can experience. And a set of possible actions it can take to affect the experiences of other agents. And when it has an experience like red, there's a Markovian kernel that it uses to choose an action. And once it's chosen the action, there's a Markovian kernel which then uses that action to influence the experiences of other agents. So that's a big social network. It's like a Twitterverse, an interacting social network of consciousness and conscious agents, where instead of tweets, you're affecting experiences, and that's it. So there's no assumption of learning, memory, problem solving, intelligence, anything like that. It's just experiences and probabilistic relationships among experiences. It's trivial to prove that these networks of conscious agents are computationally universal. So it means that I can do anything with them that you could do with neural networks. I can build theories of learning, memory, problem solving, intelligence, and so forth. So we didn't throw the kitchen sink in to begin with. We only said, what's the minimum that we could use to get a scientific theory of consciousness? Let's have qualia, experiences, and probabilistic relationships among qualia, period. That's the only thing we assume. And then we will have to build everything, even the notion of a self and so forth. We'll have to build all of that from this foundation.
But that's not a theory of consciousness. It's a theory of the content of consciousness, right?
Very, very important point. The experiences are, of course, the content of consciousness. But I have to write down a probability space first before I can even talk about the contents. And those probability spaces are the mathematical concomitant. Again, the math is not the territory, but this is the part of the math that's pointing to the void prior to experience that appears in the void. So it's
probability space, meaning a set of outcomes, sigma algebra on the set of outcomes.
Exactly, a sigma algebra on a set of outcomes.
Probability measure on the set of outcome, right?
That's right. Well, you could have a measurable space instead of a measure space. So a measurable space need not even have a probability measure on that space. It could just be a sigma algebra, right? So we could then leave it open what the probability measures are, just to have a measurable space. And so that's the mathematical pointer to the consciousness prior to any content. And then the particular Markovian dynamics is modeling the interplay of the various contents. And in some sense, then what's happening is that,
which means that all the interactions between these qualia are simultaneously present in temporal space.
Well, that's right. So you can think about there's this one huge Markovian kernel. Say that's
the set of all possibilities.
Right. So you actually, and when we say the set of all possibilities, it's actually pretty deep because we have to go all the way up Cantor's hierarchy as well. So it's not just A left 0 or A left 1. It's entire Cantor's hierarchy that we're going to have to deal with when we're talking about the one. I'm now sort of favoring the notion of the whole instead of the one. But again, those are just different pointers to the same thing, and that whatever that thing is will transcend any particular description, right?
You have restrictions of accountability is the moment you use sigma algebras.
That's right. But
instead of power sets, for instance.
Right. Yeah, you can generalize sigma algebras.
Index set has to be countable, right? Basically, it has to be n.
And all the specific work I'm doing is only in the countable space right now, right? If I'm going to build a computer simulation, I can't do anything uncountable. So, but you're right. In principle, I'd have to go beyond just sigma algebras. And what's interesting then is we can model observers by Markov kernels. These conscious agents can be modeled by Markov kernels. What the kernel does, say I have a conscious agent that is I'm modeling with a 10 by 10 matrix, right? So this is an agent that has only 10 experiences, and you're seeing the probabilities. If I have the color red experience, what's the probability I'll see red next or green next or blue or whatever it might be, for example. But then I could have an agent with 50 experiences, or one with 1 trillion, or quadrillions, or whatever, So now we want to ask, what is the relationship among these different projections of the one consciousness, right? They're all, in some sense, each of these Markovian kernels is a mathematical perspective on the one consciousness.
Restriction.
Right? It's a restriction. And so you're right. Restriction is going to be the key. And
I guess that would be the mathematical word, right? Restriction.
Yes, and in the theory of Markov chains, the restriction is called a trace chain. So if I take a Markovian kernel and on 10 states, and I just look at 3 of the states, I can then, from the bigger dynamics, induce a dynamics just on the 3 by only paying attention to what happens probabilistically among those 3. That's called a trace chain. And there's a mathematical formula that you can write down. If you give me a kernel for the bigger one and give me any subset of states, there's a mathematical formula that gives you the new Markov kernel on that subset. And the numbers are different, right? They're going to be different numbers in the probabilities. So that's a trace. So what we're writing a paper right now, we discovered a new fact about Markov kernels. This trace process gives you a partial order on the set of all Markovian kernels. One kernel A is less than a kernel B if A is a trace of B. It's that simple, but the logic that comes out of it is unbelievably beautiful. It's non-Boolean. There's no global complement. There's no unit at the top. It's locally Boolean. That is, if I take one Markovian kernel and I look at all the kernels that are less than it, they form a Boolean sublogic. But in general, and so for them, you can take the and the or of any 2 Markov chains within it, and they'll be compatible, and you can take their and their or. But in general, you can't. In general, 2 Markovian kernels are not compatible, and you cannot take their and their or. So that's why I'm more interested now in the math. See, I was talking about the one because that's what spiritual traditions have been talking about, and I thought it was a good word. But then when we discovered this trace order, I realized, well, the one could be maybe too restrictive on my thinking because it's not a Boolean logic. This is a non-Boolean logic. It's better to call it the whole. Locally, it might look like a Boolean logic, but the whole is not Boolean. And in some sense, and again, the math is not the pointer, but in this virtuous circle that I'm hoping to have in spirituality, this mathematics has come back to me and said, Don, you need to expand your notion of the one now. The one need not be like a Boolean logic at all. The one could be entirely non-Boolean with no top element. And that might be, again, that's not going to be an exhaustive statement about the undescribable consciousness.
Anyway, there is not one size fits all logic, right? The Boolean logic is adapted to our human scale. At the quantum scale, it becomes different. Actually, you can describe quantum theory by using a different type of logic, right? So
yeah, right. Or orthocomplemented modular lattices.
Yeah, and also the excluded middle doesn't apply to totality. So it's an arbitrary choice, Boolean logic and the excluded middle. Yes. So basically, at the level of the absolute, there are no restrictions.
That's right. So any mathematics is just going to be a pointer, and it will fall far short.
Yeah.
But what's interesting is that here we are the one in a particular projection, and the one is choosing to look at the world through a space-time view, through mathematics, and so that's not an accident. It's not an accident that the one chooses to project itself into a particular restricted subset of its possibilities and to look at itself from that perspective.
Yes.
And first to completely identify with that perspective, get lost in that perspective, believe that that's what it is, and then slowly wake up.
Yeah.
And in the process, by taking that perspective so seriously that you identified with it, you really take it and really internalize it. You really get that perspective. And then you realize, as incredible as that perspective was, I infinitely transcend that. And that's how the one comes to know itself, is by losing itself in an infinity of different perspectives. Our space-time perspective is just one of an infinity. But it loses itself in that perspective completely, painfully wakes up. It has the fear of death, the whole bit, but painfully wakes up.
I'm not sure about that. We shouldn't exclude the possibility for consciousness to know itself directly. Actually, my contention is that consciousness knows itself directly. The reason why, usually, why do we know that we are conscious, or how do we know about consciousness? Certainly hearsay has no value here, right? We don't know that we are conscious because dad or mom has told, or in college, Don Hoffman has told us, see, you are conscious. No, that's not how we know that. People usually believe that we know that through inference, that I know that I'm conscious because there are perceptions. That's a false inference, because for the inference process to work, let's say there is smoke on top of the hill, there must be fire on the other side. For that reasoning to work, it requires for us to have a prior experience of smoke and fire, right? A visitor from a distant galaxy, on his planet, there is no smoke, no fire, no combustion. He has never seen smoke or fire. Seeing smoke on top of the hill, he's not going to draw the inference that there must be fire, right? So if we translate that, there are perceptions, that's the smoke, therefore there must be consciousness. It requires a prior direct experience of consciousness, which is precisely that which is being denied right off the bat, right? So the conclusion is that consciousness is self-conscious. In other words, we know that we are conscious directly without need for any, I apologize for using one of your agent, right? But not in the sense of you use it, right? We don't need any agent, any broker to tell us you are conscious. No, we know that consciousness knows itself. That's really, Spinoza would say, an attribute of consciousness, an attribute meaning something, whenever you have the substance of which it is an attribute, the attribute is always present. In other words, consciousness, reality is always conscious. It is not conscious sometimes,
right.
through some beings, and at times not conscious. It is conscious. To be conscious, to be real, are in fact identical statements. The fundamental equation, if you will, of non-duality is reality equals consciousness. In India, that's Brahman equals Atman. You know, that's a fundamental equation of non-duality. There is only one reality, therefore this and that are the same.
Yes.
You are that, that's Ramasi, you are that, you are that, you are. There is only one reality. And it fragments itself apparently just to play this game, to play this universal computer game, right?
Yes, I agree. It's that one reality that you've just described is what will always transcend any description, scientific or otherwise.
And hence Gödel, right?
That's right. That's right.
Every set of axioms will be always incomplete. There will be always some true, let's say, theorem in the system that cannot be proven, a true fact that cannot be proven using this set of axioms. Then we can add this fact as a new axiom, but then we are back to square one. And
that's right. There'll be some new thing that you can't prove. Absolutely. So we're on the same page. So the question then that arises is, why does the one choose to not just be self-aware? Why does it choose to let itself get confused and believe that it's just a physical being, believe that it's going to die, and be scared about that, and so forth? I mean, so the one isn't just being capricious about this. This seems to be an important aspect of self-knowledge of the one, is to let it get itself completely discombobulated, to
experience all its infinite possibilities, right? Yes. It's like you could ask, why do we go to the movies to see our favorite character suffer in the movie and suffer with him? Because it's exciting, because this kind of suffering is fun ultimately, right?
Right.
We like the thrill of the thriller.
Well, I think that's a fair enough explanation. And there may also be a principled reason as well, that there are theorems that no system can ever fully know itself. For example, if I have a computer, right, and I want that computer, I try to build some software in the computer to model it, the computer itself. Well, as soon as I've done that, the computer is more complicated because now it has a model in its. So now I have to model the computer with a model, and it goes on ad infinitum.
And the theory of everything cannot account for itself, right?
That's exactly right. So that maybe as you said, it may be for fun, and that may not contradict that. It's also for logical reasons, that there is no other way to know yourself but to explore yourself from different perspectives. And
yeah, go ahead. Sorry. It's following my thought. There is a question, and it's way out of my level of knowledge, because biology and stuff and Darwin, it's not something I am knowledgeable about at all. But I've heard someone somewhere, don't remember, this argument that I find interesting, which is this: regarding living organisms, any feature of the organism, of a living organism, either has a current functionality, right, due to the Darwinian process of evolution, right, or is simply the leftover of a functionality which was there in the past, like a tail, right, and which over time has become obsolete, but due to the transmission of the genes remains as an ornament, but eventually will disappear, right, through the random selection. Okay, so therefore, any feature of a living thing, of a biologically living thing, has a function past or present. Now, there will be one exception with consciousness, if we see consciousness as a feature of a living organism, because in fact, already a large part of the functions of the organism, such as the immune system, or that, we are not conscious of it. It happens automatically, right? Like the running of an engine, right? So we could create a zombie or a robot which would replace, at least in a Gedanken experiment, the residual function of the brain mechanically, without consciousness, right? A robot, a zombie. So then what if that's the case, what is then the functionality of consciousness? Consciousness becomes a singularity if we see it as a feature of a living thing, because it doesn't have any obvious functionality, because it could be replaced by automatic features. What do you think of that? What's your...
Well, no, I completely agree. Now, a lot of theorists have tried to offer explanations for an evolutionary origin to consciousness, that it had some important function that was necessary for it to evolve. And they always get, I mean, it's easy to debunk them, and nothing has stood up to the test of, critical scrutiny by your peers. So a lot of people have tried to propose that. I think evolution simply doesn't have the tools, because to show what consciousness
doesn't have the use for it, right?
Yeah, there's no.
It points at the singularity of consciousness. And if we think about it, consciousness is the ultimate singularity in our experience.
Right.
I was talking earlier on of, this Geoffroy Chu, and I remember, we were sitting next to each other on a Christmas dinner, and he knew my background in physics, so the conversation moved into this direction. And at some point, I told him, would you agree that in physics and in science generally, the extent we know with certainty the phenomenon we are measuring or observing is limited by the knowledge we have of the measuring apparatus. Right? We cannot measure with a precision of 1 nanometer with something, the length of which we don't know with a precision of a centimeter, right? So he said, yes, of course. And then I say, now, if everything we know it's through consciousness, and if we know nothing about consciousness, how can we be certain of anything?
And how did he respond?
He was silent for a while. He didn't talk to me about physics or stuff. We talk about other things, the education of the children or something.
Then we talked about the weather.
but then, as I say, he came to one of mine. He's a very, very nice gentleman, very deep. I would ask him questions, and I asked him another question. What is reality for you? And he had this very long silence. And after that, he said, an operator on a Hilbert space. And I should have told
Wow.
him, what do you mean, in the Heisenberg picture or in the Schrödinger picture?
Right,
But
right,
I
right.
didn't say that because for me, it was answering on the level of concept, right?
Right,
And
right,
not on the
right.
level of experience, because it's the operator of a Hilbert, on a Hilbert space, or whether it's in the Schrödinger or the Heisenberg picture, is going to be a representation, a map. It's not going to be the territory.
Absolutely not. Reality is what I am when I let go of all concepts.
Yes, exactly.
But the
we are quite on the same page on the fact that we see a consciousness as primeval, or in my case, as the basic. We don't have too many certainties. I think I have only two certainties. One is that there is something rather than nothing, and the other one that there is consciousness.
right.
Those are two certainties. And in fact, these two certainties, experientially, I cannot have one without the other.
Right.
Right? So
right.
it's very difficult to divide them because they always come together. Right? They are like two sides of the same coin.
That's right.
And then the question I ask myself is, can I live my life in a way which is happy and harmonious, only based upon that which I can be absolutely certain of? And I have felt in my life that the answer is paradoxically a resounding yes. You see? And then I find that everything else we are interested in is like a game. I think you are interested in science. Science is a game. It's beautiful. It's a beautiful game.
Yes,
right?
Right.
We get inspiration. It's like an artist. Beethoven, Mozart, they compose beautiful music from this source. Other people, they have compassion. They are on the path of love, etc. In fact, all these paths have a common source. They all emanate out of the same reality, experience of oneness. If you and I, we are the same consciousness, I'm not going to kill you. I'm going to treat you like myself, right? So all the ethical values that we find in religion, in the books of do's and don'ts, they flow, in fact, naturally from this single certainties that we have in life. If we investigate in this direction, that's another part, of course, that is not taken into account by science, because science is a game we love playing. It's like if I heard about a new theory on the internet, I go there, I try to say, and I said, should I invest in the math, or not, because it's a big investment, you do that. I've invested in general relativity when I was in my college. We were doing special relativity, but we didn't do. So later on, I invested, in the Christoffel symbols and all of that stuff, in the Ricci tensor and the
difficult
plus energy tensor and all of that stuff, in the black hole, in the linear approximations and the spherical solutions and the application to black holes, all of that stuff. That was worth it. But if I see new theories, do I want to go really deep into string theory? No. Too much investment. I'm too old.
But it depends on our stage of life as well. But I agree that it's a game. It's beautiful. That's the healthy attitude to take toward life, as opposed to everything's so important. I'm trying to find out and make myself special by what I accomplish and am known for and so forth. To realize it's almost like when you play a virtual reality game. First player, and you have your own avatar and you're shooting up or something like that. If you know it's just a game, then you have fun. But if you actually
Exactly.
identify with the avatar, it's scary because now you're getting shot up. And so in some sense, the spiritual traditions are just telling us, hey, that's just your avatar. That's not you.
But just again, and
relax.
the problem is that in order to play the game to its fullest, to go really into it, we have to believe it to be true, right?
At least to begin with. That's right. So
Yes.
but that's part of the interesting aspect of this is that we see clearly that consciousness goes in with both feet and loses itself in many, many cases. In some cases, you know, a Ramana Maharshi or something like that, someone basically spends their whole life awake. But most of us don't. I would say 99 out of 100 don't, right? Probably more than 99 out of 100 don't. But we all have to wake up painfully, but we learn something in the process. And you know, I agree, even the mathematics that we're doing, the science that we're doing is a game. And yet there's some point in enjoying that aspect of the game, and there's some kind of self-understanding and enrichment that happens from that. Otherwise, it wouldn't be done. Do you agree, or?
Yes, yes. But you know, there is something I was thinking of mathematics as a game. You know, with this saying that God creates the natural numbers and we create all the rest, right? Right. But it's not true, because God created pi and God created e. You know, and that you start with natural numbers, right? But if you try to figure out the law of rarefactions of this number, then E comes into the picture naturally. You see, so it is this emergence out of something apparently very simple, right?
Yes.
The law of rarefaction, sorry, I misspoke, of prime numbers, right? The law of rarefaction of prime numbers, you know, there is natural logarithms that comes into place for the number e. It is that you start from something apparently very simple, and then you have this revelation after revelation that come up, and it's the maths. I mean, the Riemann conjectures, the non-trivial zeros of the zeta function, the continuum conjecture, right? Is there something between the countable set and Aleph zero, etc.? All of these elements, it's kind of a revelation. There is something sacred to that. There is something God hides in part. She hides everywhere, right? But for me, especially in the mathematics and this uncanny connection between mathematics and the world as we discover it through physics. So in your endeavor to get inspired from consciousness, to discover a new theory that could move us beyond the known theories of physics. I think I'm not sure your mathematical instrument is a proper one, but I think that the direction is interesting, and I've heard you yourself say, I'm not sure that Markov processes are ultimately the mathematical tool to account for that.
Well, I'm sure they're not. but that we have to start somewhere.
Yeah, I mean, it's an interesting endeavor. You know, it's an interesting undertaking.
Yes, it's in the process of really doing it seriously, right? By doing it seriously, even though you know that it can't be the final answer, you learn something in the process. And one thing I'll just mention briefly, the physicists I mentioned that are this European Research Council initiative that's put out the 10 million euros for the positive geometries and also the study of combinatorial objects that classify these geometries. It's something called decorated permutations. So they're going to be studying these mathematical structures outside of space-time and outside of quantum theory, by the way. There are no these structures are beyond Hilbert spaces. They're not Hilbert spaces. They're beyond that. What's interesting then is what we're trying to do is take the theory of conscious agents, which is Markovian dynamics, and show that it can project down into these positive geometries and into the decorated the combinatorial objects. Now, we published a paper last year that does a mapping from Markov chains to the combinatorial objects that they've discovered, namely these decorated permutations. So that was a new contribution to mathematics, where we actually showed how decorated permutations classify the so-called recurrent communicating classes of Markov chains. And also we discovered this year also the asymptotic sets of the recurrent classes. So what we're doing is systematically taking our theory of consciousness outside of space-time and trying to project it down to the new structures that the physicists have found coming from space-time and going out, right? They're going beyond space-time. We start outside space-time. We want to project into space-time because we want to make a theory of consciousness predict the properties of quarks and gluons. If I can predict the quarks and gluon interactions from a theory of consciousness, that will be a step now where a spiritual quote unquote theory actually is empirically testable. And that would be a first.
But can't you, I would say, can't you predict, for instance, a double split experiment, something more simple that doesn't require as many parameters like a charge, spin, color, mass, etc.
Excellent point. Excellent point. Well, and we do
which
have
is more closer to the foundation of quantum theory.
It is. No, that's a very fair point. And in fact, we have been able to derive the wave equation of the free particle from Markov chains, from our Markov chains. So, and it's a complex valued wave function that we get. So
you mean the Dirac equation, or
just the state function of a free particle. So if you take a Markov kernel and you enhance it to what they call a space-time chain. So you take a Markov chain, which is just, say an n by n matrix, but then you add one other parameter, which is a time counter. And that counter advances by one each time. So you get a Markov chain that gets enhanced to what's called a space-time chain. But this is all still Markov theory. It turns out that the eigenfunctions of the space-time chain are identical in structure to the wave equation of a free particle in quantum theory, the identical structure. And so that's allowing us to now start to make connections.
You're losing me.
I'm losing you. Okay.
No, but don't worry, because this thing requires more.
Well, it's wave function is something like e to the I2 pi x over lambda minus t over p, where p is the period. And so you have that's sort of the wave equation of it gives you an eigen state of momentum or energy for a free particle. And it turns out that when you actually look at the Markovian kernel, with the space-time chain associated with the Markovian kernel, and take its eigenfunctions, they have exactly the same function, the same format as these eigenfunctions of momentum or energy. And that's allowed us to now start writing a dictionary between properties of Markov chains outside of space-time and properties in space-time, like the momentum, which is related to the spatial frequency, and so forth. So what we're trying to do is to show that we can start with a theory of consciousness outside of space-time or Markovian model and get all of quantum theory, all of it, coming out as a special projection of a much more general theory. That's the goal. And then that doesn't mean we're right, but it does mean that spirituality, for the first time, would have a mathematically precise theory that, again, is not the territory, it's just a map, but we can then begin to start to have this virtuous circle like that as I talked about with Einstein and his theory of general relativity, right? The theory came back and taught Einstein something he didn't know about black holes. I would love for spirituality to get to the place where we have spiritual statements that are, of course, just pointers, not the territory, but they come back and become our teachers and take us deeper, just as it's done in science. That's my goal for spirituality.
And Don, are there any unanswered questions relevant to your own work which you feel could be answered through some form of spirituality, spiritual inquiry? Is there something that you're still unsure of?
A lot on several dimensions. I feel like what we've done so far is just a baby step. But the point is, it's absolutely precise so that we can find out what the limits of this are. There's two kinds of questions that I have that are very, very open. One is, I need someone who knows the mathematics of these positive geometries to collaborate with us to help us map Markov chains onto the positive geometries, things like amplituhedra, associahedra, and so forth. So I've just gotten funding for a postdoc, and we're going to be trying to hire a new PhD who actually knows this stuff, a mathematician who knows this stuff, to help us make this map. So that's one area where I need more help. But your question was more about the spiritual side. And I would say, I feel like a babe in the woods. I feel like all I've done is say, here's a mathematical model in which there are conscious experiences and their relationships. And I'm just seeing how far that can go. I feel like that's just putting your toe in the water, but you got to start somewhere. So I'm putting my toe in the water. I'm trying to see how far I can get with that and how much that can teach us, and then go to the next step. So I go into this knowing full well that Markov chains aren't the final word and my theory is not the final word. But we have to take this precise statement, because it's the simplest one we could come up with, push it as far as it can go, and then that will be our tutor as to what a next step might be. So I would say, Jenny, almost every question that you can imagine is still on my plate.
It sounds like there's a huge amount of scope for a further discussion between you, but maybe we've come to the end of the time that you have available just now.
Yes, thank you. Yes.
Thank you both very much. It's been absolutely fascinating. I haven't understood all of it, but I shall listen again and work it out.
It was a great pleasure and very, very great to talk with you, Francis and Jenny.
Same here, Don. Yes.
Yes.
Very informative and very nice. I think we share the fundamental aspect.
Completely. Yes. Yeah, I agree. It'll be fun to explore it further.
A love for maths and physics.
Exactly. Geeks as well.
Yeah, I was sure that you would.
Okay.
Okay.
We'll talk again. Okay.